Good morning, everybody. This is Jerry Pohorski, president of the Silicon Valley chapter of the Electric Vehicle Association. I'm actually wearing my EVA shirt here. Yeah, logo. Okay, anyway, we have with us today Sean McCluskey, owner and founder of Trajectory EV down in Salinas, Ron Freund, who's on the call now. And I went down there a little while ago with Billy Caruso, who had a RAV4 that definitely needed some help. And so Sean gave him a couple of options. He said, hey, I could replace some of your nickel metal hydride batteries, or I could upgrade you to lithium. And he's got a very cool lithium upgrade. So I'll let Sean talk about that. And without any further ado, Sean, you want to go ahead and share your screen?
Absolutely. Let's see here. All right, can everybody see my screen here?
Yeah.
Yes.
All right, here we go. Okay, so Zoom quit unexpectedly.
Oh, bugger.
I can still hear you.
You can still hear me, but you can't see me.
Well, I can see your slide.
Restart the video.
Okay, let's try it one more time. So far, we're good?
Yeah.
Okay,
So far,
great.
it's up.
Okay, awesome.
Good.
Sweet. Okay, so let's see here. So I gotta be honest, I haven't always been an EV nut, but I've always been a car nut. Grew up in a family, 3 generations of car nuts at least. And to be honest, I just didn't know that EVs existed. I didn't grow up around Silicon Valley, didn't grow up around anywhere where EVs were a thing, even in the, even recently. So when I moved out to California for college, I started noticing them, looking at the engineering behind them, and realized that this might be the perfect combination between my dream of vintage vehicles and my I wouldn't call it a dream, but the sensible outlook of making sure our planet might last a little longer than at least my lifetime, which would be awesome. So I about a year and a half ago launched Trajectory, and since then we've grown the team. So this is me over here on the left. We've got Bob, who works here in Salinas. Jesus goes back and forth between our Mexico office and the US office. He's setting up the Mexico office right now. We'll talk a little bit about that. And then Zoe takes care of everything for us in China. And we'll talk a little bit about why we have a Mexico and a Chinese entity in addition to the US, and why that's really important for us to be able to offer what we do offer in the US. But first, let's talk a little bit here. So we started in 2020. Our official first day of business was January 1st, 2021, or January 3rd, maybe, because I think it was a Monday. Here in the US, we specialize in converting vintage vehicles to electric, as well as repairing and upgrading what we call first generation EVs. So that would be RAV4 EV, Ranger EV, EV1, if anyone ever brings one in, vehicles of that generation. We do have a lot of experience with the packs that these vehicles have, but more importantly, we want to keep them as original as possible, and if possible, keep them so they can be converted back to the way they were originally, if the owners ever wish that to be the case. So we're very against cutting holes in things and grinding away pieces of the pack and things like that. So I'll talk a little bit about the US entity here, and then I'll pause for questions before I go into the other companies here. So first, we're in Salinas. This is where Jerry stopped by a month and a half ago or so. So we have 4,800 square feet online right now, with another 4,000 coming online fall of next year. We've got a few very large vehicle lifts. You know, we do occasionally have to lift things this large. We're doing a conversion here in the next couple weeks on a 6-wheel drive military passenger carrier. So it's quite large. 3 hydraulic locking differentials, and you know, big vehicle. We have really amazing access to the highway, so it's really easy for us to get lots of places and for people to get things to us. And we do have a ramp truck, so we can pick up and drop off vehicles wherever they might be. As long as they can roll, we can go ahead and pick them up and drop them off. And we find that really important to save our customers some money, not needing to call tow trucks every time they send something to us. We'll talk a little bit about these specialties here. So for the RAV4, we can characterize and restore the OEM packs if they're not in too bad of shape. In some cases, they're in really, really bad shape, and that's just not possible. In that case, we can replace the original pack with a lithium iron phosphate pack. And we'll talk a little bit about that shortly. I have some pictures and some diagrams I can show about what's very special about that replacement. For the Ranger, we do pack upgrades on those as well. We also do what we call touch up to the bodies. So we go in and swap out the headlights, and we have a shop that helps us. They do any paint touch up and things like that. So these trucks are as beautiful as they were originally, and highly functional. So up to 73.5 kilowatt hour, which for a Ranger is well over 200 miles. And then very soon we will be offering CHAdeMO and CCS on the Rangers with the large pack. So with the largest pack, you'll also be able to add the option of CHAdeMO or CCS. And then for the general conversions, we typically stay in that 360 volt range, about 200 horsepower. We try not to go crazy. But for some systems, you need to go crazy. For example, we're building, right now we're building our shop's new tow truck. We want to get away from the big turbo diesel V8 and get to something electric. And for that truck, it's a full 800 volt pack that peaks out at about 1200 amps. And it's a Dana 80 rear end. So the rear end is a big dually rear end rated at 11,000 pounds or something like that. So, you know, sometimes you really have to crank up that system to get what you need out of it. But generally we like to stay pretty reasonable. Now, before I go into the RAV4 and the EV95 replacement cell development pictures and stuff, any questions so far?
Sounds like we're good to go on. Let's continue.
All right, here we go. So the EV95 is interesting because it's a 12 volt module, but it's sort of a weird packaging. And so we wanted to create a true drop-in replacement module. But in order to do that and still use all the factory harnessing, you have to get the terminals to the right location, and you have to get the voltages right and all of that. So what we ended up coming up with is this drop-in replacement module here. So this is on the right, or sort of in the middle, you'll see the stacks of these tan cells. This is what the original EV95 module looks like. So this is 10 nickel metal hydride cells in series, each with a nominal voltage of 1.2, which gives you a 12 volt nominal pack. And the cell negative terminal is right here, and the cell positive, or the module positive terminal, excuse me, is right here. And it is a sort of weird configuration because there are so many cells. So in order to match this, we engineered this module that is 4 lithium iron phosphate cells in series. And these are, the original is 95 amp hour. The lithium iron phosphate is 154 amp hour and significantly lighter. But it's in this aluminum compression casing to make sure that your cell compression is proper, secondary insulation. Then it has these bus bars that allow us to relocate the positive and negative terminals to where they must be so that we can use the factory harness. So in terms of keeping the pack original, what we can do is basically open the pack, disconnect the computer and the PCM, lift out all 24 modules. If we're speaking about a RAV4, we'll lift out all 24 modules, drop in 24 of the replacement modules, reattach the harness because we have the exact same pin location or terminal locations. And then each module, each one of these replacement modules comes with a built-in cell tap harness. And what you see on the right is the prototype here. So the finished version is more polished than this, but you'll notice that it has all the features. And it's sitting in the original nickel metal hydride casing that comes out of the Ranger. So it fits perfectly down into that casing. And the height is identical as well. So then this cell tap can be used in one of 3 ways. You can either have a module level BMS that monitors and balances these 4 cells individually, or you can tie this into the factory BMS if for some reason you want the cells to talk to the factory BMS. I don't know why you would, but you can. Or you can use these to tie into a secondary BMS that monitors the lithium cells and talks to the new lithium charger, so that the nickel metal hydride BMS stays in place and still runs the gauge cluster and all of the dash gauges and everything. And the lithium iron phosphate BMS manages the batteries and balances them and communicates with the charger so that you are allowed to use J1772 and keep the cells all balanced and healthy and stuff. And so we're really happy with the prototype on this. We're building the first run of these production modules soon. We've got two cars lined up for these to go into in the next month or so. And then as soon as we finish those, we'll compile everything, and then this will be available either as a kit that people can buy and do themselves, or as a service that we can do as an upgrade. And in terms of the upgrade itself, cell capacity goes from 95 amp hour to 154 amp hour. Your conversion efficiency at 1C goes from about 70% with nickel metal hydride at 1C to about 92% in lithium iron phosphate at 1C. Now, the conversion efficiency of nickel metal hydride, this is the amount of energy, the amount of useful energy you get out of a cell that contains X amount of energy. So if you have a cell that contains 1 kilowatt hour of energy, if you draw that energy out at 1C, you get 70% of it from a nickel metal hydride cell, and the other 30% goes to heat. Whereas you get 92% of it out of the lithium iron phosphate modules, only 8% of it goes to heat. The effective capacity is 19.15 versus 43.52. So the capacity goes up pretty dramatically. In fact, it goes up significantly more than the cell capacity, and that is simply due to the difference in conversion efficiency at 1C. So this really depends on the way you drive, but based on what we're seeing, it's about this. And the estimated range using the EPA estimated efficiencies goes from about 95 miles with the original healthy, brand new nickel metal hydride pack to about 175 miles. And it could be higher or lower depending on the way you drive. Of course, you all know this, but that is roughly the delta there.
Hey, Sean, could I ask a question?
Absolutely.
Ben White here, by the way. Looking at this slide and what you just said, it seems to me this explains why no manufacturers are using nickel metal hydride anymore. Am I right?
Absolutely. Yep, absolutely. Yeah.
Okay, thank you.
If I could ask a quick question, this is Mark Geller. I've got a 2002 RAV4 EV that I still use daily with the original pack. Why do you say the effective capacity of the original RAV4 nickel pack is 19.15?
Yeah, so so nickel is the effective capacity, meaning how much energy you can draw from the pack, is very susceptible to change based on how you drive it. So if you drive very conservatively, your effective capacity could be much higher. It could be with a brand new pack, you could be 25 kilowatt hour or something like that. But if you're pulling 1C, so if you're pulling 95 amps continuously from this pack, so if you're driving on the highway or you're accelerating, decelerating, then your effective capacity drops.
Okay,
About
that's great. I mean, I happen to drive, no offense intended, like a little old lady. So
you probably get more capacity than that.
Yeah. Okay, thank you.
Yep. Any other questions? Okay, we will move on. Let's talk a little bit about the Ranger pack replacement. So people have been doing Ranger pack replacements for a long time. The Ranger lends itself very well to, let's just drop the pack and do all sorts of crazy stuff in this box and then reattach it and see what happens. It's very forgiving. The components are extremely well engineered. And the original pack was nowhere near as well designed or as tightly packaged as the RAV4. So there's only one more module in the Ranger pack than there is in the RAV4 pack, and they use the same modules, but the volume of the battery pack is almost double. The packaging is atrocious, which leads to much better sort of community ability to DIY it, right? So historically, there have been issues with Ranger conversions, things coming loose, cells failing, voltage leaking. And this isn't every truck or every person who does conversions. This is just a general topic, right? And there's also the different use case. These are pickups, and people use them as pickups. They have double the payload capacity of the gas Rangers because of the suspension upgrades that Ford made. So people use them as pickups. They bounce around, they, jiggle and move around, and they're suspended much differently than the RAV4 packs. The RAV4 packs have, I believe, 20 bolts that hold the pack into the chassis, and the Ranger has 6. So they're sitting on floating grommets. So there's very different interactions there. So what do we do differently? So we're a huge fan of right to repair. That's something we really believe in. So we engineer our packs for the Ranger, well, for everything, but specifically for the Rangers, with all of these situations in mind. And so just a few differences here. So all fasteners, we torque them to a set specification. We provide those specifications to the customers. If the customer wants to go in and change something at a later date, when they drop that pack, they know exactly what to torque it back to. They know exactly what to set it to. All cells and modules are compressed to the factory data sheets, so we don't have premature cell failures or any cell leakage, because we have redundant insulation between the cells, and we provide the wiring diagrams. Right? I mean, our specialty here is the expertise in engineering and building these things, but we're not creating proprietary information in the sense that we might have special parts that we use, for example, or things that we've designed and manufactured and incorporated. But in every case, the user has the right to repair something that goes wrong at a later date if they wish, and we provide that information. So that's our big difference here with the Rangers. Any questions on the Rangers? All right. Cool. Any questions on anything we do in the US before I move on to the 2 international sites? I can see Peter has a
So perhaps I have a question there. sort of back to the RAV4 thing. I was waiting to see what you were going to say about the RAV4 because or the Ranger, because obviously it's the same battery module. So from the diagram that you showed up earlier, it looks like you're running eight lithium cells in that same 12-volt module space. I'm guessing that that's two sets of 12 volts in parallel, which is how you're getting the 175 ampere hours. So those must be like 75 or 80, 85 ampere hour individual lithium cells, and there's 8 of them in that module. Is that right?
So there's actually only 4, and they're 154 amp hour each.
Oh,
Yeah.
I see.
So there are no parallel connections, right?
I see. So they're an unusual shape. They're long and narrow
Yeah,
rather
they're very weird shape. Yep.
compared to the traditional Caleb kind of a shape. Well,
Yep.
very
And they're also unique in that the positive and negative terminals are not on the same side of the cell.
right. Yeah, and that's why you've done that whole mechanical engineering thing there with the straps and stuff. So that's good. So obviously you haven't touched on what the cost is, and perhaps you'll get to that later.
Yeah, so I can talk a little bit about it. You know, traditionally, I found a couple examples of drop-in modules. I don't know if they've functioned or not in the past, and they've been upwards of $600 or $700 a module. I thought that was ridiculous. So our cost on a full conversion for a Ranger is between 17 and 18,000 to go to the full lithium. But that's including labor and everything. The kit is less than that. And these modules, if you just want the modules, we sell these drop-in modules for between $300 and $400 a piece. And the reason I'm giving ranges is just because of volume pricing. We don't know how much interest there will be, so we don't know what the volume that we can order at the same time will be. You know, if we order 2 sets, our volume pricing is not that great, but if we order 10 sets, it's substantially better, which is why there's ranges at this point.
You said 17 to 18,000 if you do it, and you said for the Ranger. Did you mean, is that just the Ranger, or was that for the RAV?
Sorry, I said that's the range in cost.
That's
the RAV4. So for the
Okay.
Ranger, we actually don't use these modules for the Ranger.
Okay, great.
And the reason is because the packaging in the Ranger is very different, and we can actually get substantially more energy into that pack.
Got it.
Yeah. So we go from 154 in the RAV4 to 230 amp hour in the Ranger.
Hi, my name is Damu. I have a 2003 RAV4 EV, and I used to get like up to 95 miles range on a full charge.
Mm-hmm.
It has recently dropped down to like about 45, 47. I mean, one of the reasons being I don't use it that frequently after the COVID, work from home scenario.
Mm-hmm.
Before I used to drive to work as a commute car, but these days, I just use for the grocery store here, just local trips, Said that, it dropped down the range from 95 on a full charge, 95 miles on a full charge to like about 47. It's like a 50% cut in the usable range, right?
Mm-hmm.
So my question is, when I still use the original paddle charger. I think that's the only way you can charge those batteries. At the end of the charge, the charger shows like 4 fully lit LEDs. So my question is, am I wasting current trying to charge it fully since the range dropped down by 50%? Or what's really happening here?
So there are a couple things that can be happening with these modules. So there's a few failure modes here. So the first and most common failure mode in a situation like you just described is that one or more of your cells has dramatically increased in internal resistance.
Mm-hmm.
And the way that charger, the onboard charger from the RAV4, the way it senses when the batteries are full is by something called reaction voltage. And so basically it's charging. When you're charging a battery, the voltage is increasing, right? But nickel metal hydride, when you reach a certain point at a certain internal resistance and at a certain voltage, the voltage will start to decrease again. And that is the definition chemically of when a nickel metal hydride battery is fully charged. But it's very hard to detect that sometimes. So that charger occasionally looks for a dramatic increase in internal resistance that accompanies that voltage drop. And so if you have one or more cells that is dramatically high in its internal resistance, you can get an early shutoff. So your charger will detect that it's full and shut off early. And we see that a lot in RAV4s that have had great range and then suddenly dropped in range. It's not necessarily that they've dropped in range, it's that the charger is being shut off early because some of the cells have a much higher internal resistance. The other thing that could have happened is that it sat at a very low state of charge for some amount of time, and the chemistry is simply degraded inside each cell, in which case you might see the capacity of the cells just decreased. And in that case, you would see the capacity go down, but the internal resistance only increased slightly of all the cells. And in that case, there's really not that much you can do. People talk about shocking nickel metal hydride cells and sort of doing all sorts of crazy things to them, but those are all temporary. At the end of the day, if they degrade in capacity, they degrade in capacity. That's just what they do. So we need to get a computer on there to check it out to see what the specific issue is. But those are a few examples of conditions that could be causing that problem.
Okay, one thing that I noted was, the charger still takes the same amount of time like before to get to the 4 LEDs, indicating it is fully charged. So there's no reduction in time as such that I can see for the charger to reach the fully lit 4 LED condition. So basically it is still the same time it's taking to charge, or at least that's what it shows to me.
Yeah. So for example, in this slide, you see there's this conversion efficiency, and that's the efficiency of which you can get energy out or extract energy from a cell. There's also a charge efficiency. So when you put in energy to a cell, how much of it is incorporated into that cell versus wasted as heat. And nickel metal hydride cells have a very highly varying charge efficiency. And actually, the way that they determine balance is based on temperature. So when you charge a nickel metal hydride cell, say you'll notice that if you look at one of these modules, if you pull one out of a car, there's no active balancing feature on this module. It's just 10 cells in series, but somehow they stay balanced. And the way they stay balanced is by slightly overcharging them. And so when you start to charge them, the ones that are full get warm and they don't take any more current. They just waste off as heat. And so that's why if you map the degradation of these cells, the cells in the middle of the module have degraded more than the cells on the edge of the module, because the cells in the middle, the heat is trapped more. And so that heat has degraded the cells in the middle more. So it might take the same time to reach the end of the charge because it's still doing that balancing step, regardless of how much energy is being absorbed by the cells. It's still putting the same amount of energy into the pack. More is just being wasted off as heat, for example.
Okay, got it. Okay, actually, you mentioned that you can hook up a computer to see what is going on with the battery condition, right?
Yes.
Actually, I am in Fremont in East Bay, and I think your shop is in Salinas, right? It's like about 60 miles, something I checked.
Mm-hmm.
So I'm not sure if I can drive the car over there with the current range of like 45 miles, that is for the local trips on the highway, maybe even less. So how can you go about it? Like, would you send a tech to my place if I want to?
Yeah, we do offer that diagnostic service. We can send somebody out and plug in, and yep.
Okay, I will get in touch with you offline then. Thank you.
Okay.
If I could, quick question there, Sean. You mentioned, of course, you try and keep these cars, as they were. And I'm wondering what you do for charging on the RAV. Where do you put the J connector and that sort of thing?
Yeah, so if we upgrade to lithium, we obviously can't use the paddle.
Right.
So we do change to the J1772 connector, which a lot of people like because suddenly they can use all the infrastructure that already exists out
Yeah,
in the
of
world.
course.
We put it behind the paddle flap, and
Uh-huh. Oh,
and
wow.
the paddle flap button in the passenger compartment we keep working. So it's the same method. You pull up, you push that little button, the flap opens, you go over there, you plug in. When you're done, you close the little flap. So we keep that infrastructure the same.
Okay, well, my button doesn't work. I just have a piece of Velcro holding that thing down. I assume that would work fine.
Okay, maybe we can look at your button.
Okay, thanks.
Yep.
Hi, this is Marcos. I no longer have my RAV, but the question is, what is the charge rate? Is it a 7.2? I came late, so we may have already answered this.
I didn't answer that. It depends on what people want. So we can, for the RAV4s, we can do everything from about 3 kilowatt, all the way up to about 9.9 kilowatt.
Yep. So good. So there's an option for 10 kilowatt, quotation marks charging.
Yeah, 10 kilowatt quotation marks plus or minus, but yeah, exactly. Yep. And we use a charger that's sort of an interesting configuration. I don't know of any other shops in the US that use it. So it's a small module, and it's a 3.3 kilowatt module. And you link them together, and there's a sensor connection that talks from module to module, and they have the same voltage. They communicate over the same CAN bus, but their current sums as you add them. So if you want 3.3 or 6.6 or 9.9, or continuing up as you go, you're limited to the current rating on the J1772 connector, but if you put in the amount that works best for that vehicle, or the number of modules that work best for that vehicle, and link them together.
And just my last follow-up question is, would there be any option for SAE DC charging?
On the RAV4s, we've not looked into that. It's theoretically possible, but we have not explored that on the RAV4s. The capacity is not super high, and the cooling is not super great. So even if we did implement it, chances are, the way we programmed it, you'd still be limited to maybe 40 kilowatt, 50 kilowatt, something like that. You'd never approach the 200, 300 kilowatt that the specification is designed for. But still, 40 kilowatts way faster than 10 kilowatt, right? So, but as of right now, no.
Yeah, I still drive my 2011 Leaf, and I'm happy with 40 to 50 kilowatts, which is what I get. To make the car usable without DC charging, it's a lot more difficult.
Mm-hmm.
Hi, this is Damo again. So I see that you mentioned you are going to replace the factory nickel metal hydride with the lithium phosphate batteries for a full conversion. So I'm guessing, obviously, the charge controller and the battery management systems, those will be replaced for the nickel metal hydride chemistry as well?
Yeah, so the charge controller, the onboard charger gets replaced. The battery management system is not replaced. We simply add an additional one on top. And so the original one, the original one is passive. meaning it can't do much when you're not charging. And so the original one we keep so that it can run the gauge cluster and communicate with the car in many other ways. And we simply add a second BMS on top, and then add the charge controller, a lithium CCCV charge controller.
Okay. And with the full conversion, is there anything that the driver should be aware of, or any limitations or in speed, or any special things that need to be done while charging, or?
No. Well, there's one limitation that we're working on right now, which is at some point we know that the factory BMS will reach the end of its Coulomb counter. So it's counting the total number of electrons that have been used since your last charge. And at some point it will reach the end of some clock, and it will tell the car to go into turtle mode. And we think that will happen prior to the full 43 kilowatt hour usage. And so that's a problem that's already been solved on the Rangers. And so we're looking at porting that solution over from the Rangers to the RAV4s, to sort of trick that computer into not shutting down early. And that's something that we hope to have solved within these first two vehicles. And then that would be the only caveat, but it's something that we hope we don't expect to be an issue going forward. Other than that, we actually solved some of the major issues with the RAV4. So probably the biggest issue with the RAV4 is that there's no proximity sensor on the charge paddle. So many people have driven off with the paddle connected. And so you see people's paddles like duct taped together or zip tied together. And when we go to J1772, you now have a proximity line. So that won't happen.
Okay, got it. Thank you.
Hey, Sean, this is Billy. I have a quick question.
Yeah, hey, Billy.
Thank you for the presentation. Very well put together. I appreciate all the details. My main question is around the longevity of the car with the new batteries. Obviously, the RAV4 has lasted 20 years. Does this give it 20 more years or potentially more?
Yeah, so if we just go based on the cells themselves, these cells are rated for about 3,000 full cycles to 80%. So that's 3,000 cycles to 80% capacity. So if we say it's a 175-mile range at 3,000 cycles, that's 525,000 miles to 80% capacity. So in terms of the battery cells themselves, I would say easily another one or two times an additional one or two times the range the vehicle has already gone through, possibly much more. The original nickel metal hydride cells were only rated to 1,000 cycles to 50% capacity, if I remember the data sheet correctly, which would put them at 175,000 miles to 50% capacity. And they didn't all make it there, but in a perfect world, that's sort of what we're seeing, is if the cooling would have been perfect in the pack, we would have seen about 175 miles. Most of them are dying around 100 to 130,000. Does that answer your question?
Yeah, that's exactly what I was looking for. Thank you.
Yeah, the cells are rated for about 500,000 miles. There's other factors, of course. There's mechanical parts of the car and motors and inverters and all that stuff, but the cells are about 500,000.
I just want to mention that Robin has asked some questions in the chat, and some of them are questions I wanted to ask as well. So I'll let you in your own good time get to that.
Sure, I'll take a look at these. Okay. Is it okay to ask a question here? Yes, of course. The batteries will still be considered air-cooled batteries. Yes, they're still air-cooled. The nice thing about these is that the C rate will be much lower than the nickel metal hydride cells. So if you pull the same current from a 95 amp hour cell as you pull from a 154 amp hour cell, your C rate will be lower, which is great. And the heat generated will be much lower. So while they are still air cooled, the heat generated from the process is lower. Also, the gauge in the dashboard will still reflect the state of batteries as they did before with the nickel metal hydride batteries. Yes, they will. And if we find in the first two vehicles that that they're reflecting the right values, but there's a mismatch. So let's say, for example, this pack runs a little bit higher voltage than the nickel metal hydride pack, for example. We can create an analog tuning board that will just correct for that difference. But yes, the gauges will still reflect the state of the batteries and everything. Will there be a possibility of hooking up to an updated display like with the Palm Pilot app? Yes, absolutely. So that is something that will be integrated right away. We already have a solution for that. Again, given our propensity to keep these vehicles as original as possible, we prefer to install a wireless link so you can link your phone to the car and have that display on your phone. But if someone does certainly want a screen, we can link up the screen. But that data link will be there. It's already there in the current version. Are there any warranties associated with these? Yes, the cells, well, all of the components have factory warranties. I would need to go look at exactly what everything is. But yes, all the components have warranties. And on top of all the warranties, like we said earlier, we really believe in right to repair. So we want to make this as seamless and as easy as possible. So we provide that information in addition to those warranties. Awesome. Okie dokie. I'll move forward a little bit here. All right, Mexico. Why Mexico? All right, two main reasons: sourcing and restoration. So I'm actually going to start with restoration, even though we read left to right. So the cost to restore a vehicle in the US has increased dramatically. Anybody who's really into vintage cars will realize that it is skyrocketed. You know, if you had a car and you just wanted it stripped down and painted and put back together, you used to be looking at like 30 grand to do that. Now you're looking at 80 to 100 grand to do a frame off restoration, assuming everything else is good. It's getting crazy. So we're developing a location in Mexico where we can, at first it's going to be a sort of a place where we can have the vehicles and we can find local shops to work with, and we send them the vehicles to restore and bring back, and then send them back to the US shop for conversion. But eventually we're looking at building our own body shop. And the benefit of having our own body shop in Mexico is that we can have the EV specific components integrated at the time. So imagine you have a frame, you paint it, then you send it to the US, then you grind off some of the paint because you have to weld in mounts for battery boxes or something like that, or mounts for component mounting, and then you have to retouch up the paint. Well, that's annoying. I'd rather just have those components go down to Mexico with the car. They get installed, they get painted once, come back, and we do the installation, the wiring, the tuning here, and you're ready to go. And then the other one is sourcing. So a lot of people don't know this, but many of the high quality EV parts are made in Mexico, not just for conversions, but for OEM cars as well. For example, Amphenol makes almost all of the high voltage DC connectors. TCS, TE Connectivity, they have a production site in Mexico, and they make all of the contactors that are used in basically every car. And it's fantastic how many great high quality parts are made in Mexico. So we also offer sourcing as a service in addition to the sourcing we do for ourselves. So if there are parts that someone needs directly from Mexican companies, we handle the import, customs, duty, everything like that. Mark in the chat says, I have bad manners to live 500 miles from Salinas. You in better than any shippers yet. Should I need your services, or do you do your own hauling? Well, Mark, we have our own ramp truck. His name is Henry, and he's all of us think he's the best truck ever. We absolutely do our own hauling. So that's no problem. Jay says, sounds like the 3.3 kilowatt Thunderstruck chargers. Are you using dilithium BMS, Orion, or so we're not using the Thunderstruck chargers, but we are using the Orion 2 BMS in most cases. The Orion 2 BMS is wonderful for most of what we're doing here. In some of the extremely high voltage cases, we may not use the Orion BMS. So in the 800 plus volt packs, we may not, but for everything else, we use the Orions. Our chargers are not the Thunderstruck chargers. They're actually called long run chargers. They're from a company in China. A person that I've spoken with wants to buy a Ford. That's awesome. I'll get to the contact information here at the end of this. I don't want to run us over time. I know Jerry's been wonderful to invite me, and I want to stay on time with that. Any questions about Mexico before I move to China?
Go forward.
Okay. Yeah. So Shenzhen. Okay. So why China? So if there was a company that made high quality lithium cells in the U.S., I would buy them, or in anywhere in North America. The truth is that every lithium cell made in North America has already been spoken for by a vehicle OEM for the next about 20 years. So there's really no way. So the best quality cells in the world outside of the ones being made in Nevada, basically, come from northern China, and they get sourced through Shenzhen. And so we have a sourcing company under us that works just for us in Shenzhen, and we can source components, battery cells, design engineering for any metallic or polymer components, PCBs, and again, we handle shipping, customs, duty, all of that. There are a lot of fantastic parts that come from China, and we wanted to make those available to the community. So I'll do a quick summary, and then I'll answer a lot of the questions here. We've got a lot more questions in here. Here we go. Okay, so Trajectory EV in the US. So we have conversions of combustion to EV, specializing in vintage pickups and larger trucks. Restoration and pack replacement of the Ranger EV, the RAV4 EV. Trajectory Mexico, so sourcing from Mexican companies like TE Connectivity, Amphenol, things like that. Vehicle restoration services, Trajectory Shenzhen, so we're sourcing from Chinese companies, specifically EV components, cells, things like that. And design and manufacturing services for metals, polymers, PCBs. And then I will just put up the contact information here while I answer questions in the chat. Okay. Lad says, I heard you and Henry went all the way to Minnesota to put a pack in a Ranger. Yes, that ironically, that was not a Ranger, a Ford Ranger. That was a Polaris Ranger, an electric Polaris Ranger. And we did that, and the range went from 10 miles to over 100 miles. Which was a lot of fun. Tom says, I have a 2002 Ranger with nickel metal hydride in Lakeport, California. Okay. No, it's factory, not running. Okay. Sybil says, give it a call today. Okay. Mustang EV that's been in an accident and used the electric parts to convert an old Ford F-150 pickup to electric. Sybil, question, what year is this old Ford F-150 pickup?
I don't know.
Do you have like a decade, a rough decade?
It's probably about 15 or 20 years old is my guess.
Okay, so the big question here for us when we say vintage, it's really what we really mean is, does it have a wiring harness and a security system that's tied into the engine and fuel system? That's what makes this insanely difficult. That's what makes this so painful, is if we have to tie into that system. If it's pre that, then it's totally doable. If it's in that era, then that's not something we would take on. Are you thinking of hauling other vehicles, handling other vehicles? An IMEV that desperately needs help. Sure, yeah, that's a vehicle we can work on. That's no problem. I think I might even have the factory Mitsubishi computer that we can plug into that, maybe. Lawrence, question about an air-cooled 1980 Vanagon. Yes, your hand's up. Go for it, Lawrence.
Yeah, so I've got this old Vanagon. It's in good running condition, but it's the Westphalia pop top, full camps kit inside, stove, sink, water tank, and all that. Are you already doing conversions for ICE vehicles, or how far down the road would something like that be on your radar, and how much would I be looking at for a conversion like that?
Yeah, so we are doing those. I'd have to look at it before I can give a number. It really depends. For every new vehicle we look at, it really depends on where a small change in vehicle chassis configuration can make it a huge headache. And, maybe there's a nice convenient place to put everything, and we really just have to look at it. But yes, it's doable. Especially if you're looking at not small, but reasonably short jumps between locations. That's especially doable for most Volkswagens. They tend to have a pretty great motor configuration for this.
When you say short jumps between locations, you mean a low range vehicle?
Yeah, not necessarily low range, but not an exceedingly high range. So 100, 150 miles, something like that's probably reasonable. But if you're trying to go for that 300-400 miles in a vehicle of that vintage, especially that vehicle is sheet metal unibody, so there's really no frame for us to hide anything in. We can't really build integrated boxes. It has to all be in volumes that already exist, which gives some more constraints to the pack.
Yeah, would you put the pack in where the fuel tank is currently, or would you possibly hang something below the frame, which would lower the ground clearance, but there's a lot more space to work with?
It really depends. If we put one only where the fuel tank was, we wouldn't have very much capacity, because the fuel tank in that thing, I think, that's only a 25-gallon tank, 24-gallon tank, something like that.
Maybe even less. I'm not sure. It's been a long time since I filled it all the way.
Yeah. I don't think that's very much volume. But yeah, we just need to look at it. Okay.
Then a ballpark figure for price for converting an ICE.
So we've done everything from the high 20s to like the 150,000 mark. It really depends on what you want. Now that 150,000 mark, that's like a SEMA ready truck, right? That's not what any of us would consider a daily driver. But that's the general range.
Thanks.
Toyota RAV4 EVs from 2002, 2003 battery upgrades. Can you do that, Ramiro? Yeah, in fact, we can do that. If you want to send us a text or an email here, we can do that. Looking at ICE to EV conversions, what make models have proven the easiest, least expensive? Oh yeah, that's easy. 50s through 70s light duty pickups. are by far the easiest for us to do. They're fantastic. There's tons of room. They have great gearing already. We keep the transmissions. We keep those old 4 speeds, 3 speeds, 5 speeds. They're fantastic. There's tons of room in the frame to put battery boxes. You can go, lithium iron phosphate. If you want more range and more cost, you can upgrade to, the different lithium ions, the cobalt manganese oxide, that kind of stuff. Email me your direct contact info. Ramiro, it's right here on the screen. Is my screen still sharing?
Yeah.
Yes,
Okay.
it is.
Yeah.
I see it. Thank you.
Definitely the 50s through 70s pickups are by far the easiest to convert out of everything. Jose says, hi, you mentioned eventually working on EV1 if it appears. Any experience with the OEM Chevy S10 EV and EV1? So no experience at all with the EV1, other than just looking online at architecture and general configurations and stuff. The S10 EV, I've seen a couple of them. We are building modules for one right now and looking at building modules for another one, but no direct experience. We've never had one in the shop directly yet. We've done a mid-80s VW Rabbit pickup. Was it diesel? Have not done one, but seems doable. Again, Volkswagens tend to be very, very favorable to conversions. That's why the Bug and the Bus were such a big deal in the 90s for conversions, because they were really the first vehicle that lent itself to conversion quickly and easily.
Sean, Mark Eller again. My dream electric vehicle is a 1960s or 70s era Citroen DS or ID.
Okay.
Do you know the cars?
I know the cars, yeah.
Okay, yeah, I had a series of ID wagons that were fantastic, but any thought about that? Doable? I don't have a car anymore, but
yeah,
my dream car. That's all I can say.
Yeah,
and the hydraulics obviously create a particular issue.
Yeah, that's the hydropneumatic era, right?
Oh yeah.
Yeah, so the big challenge I see is that those Citroen hydropneumatic suspensions were tuned to very specific vehicle weights. So we could match the vehicle weight, but you may take a hit in range to match that vehicle weight exactly. And to me as a car guy, that hydropneumatic suspension was the greatest thing about those cars.
Oh, it was a trip.
So I would hate to have to get rid of it in order to give you a reasonable range.
Yeah, I mean, I know that somebody in Canada, it's somewhere on YouTube. I mean, I saw many years ago, took a DS and converted it. I don't suspect. I mean, obviously it was a different era. I have no idea what kind of cells he used. Either very early lithium or maybe it was even lead acid. I'm sure he didn't have great range, but he had a really awesome silent Citroen, which is great. All right, well, who knows? If I run into a body, you may hear from me about that.
Yeah, I'll look into it and see what the weight difference would be, and maybe we get lucky and it had a really heavy motor and transmission, and that'll help.
Probably it was a heavy car.
Okay, that's everything from me, Jerry. If there aren't any more questions, I can hand it back to you.
Yeah, last call for questions. Anybody have anything that they've been dying to ask?
Maybe I'll jump in. It's Peter here up in Canada, neighbors to Eric on the other side of my screen. I just jumped over to your website there to have a look at what you've got going on there. I don't see anything on there about this particular RAV4 conversion, and so definitely interested in that. And I was doing some off the cuff math there, and I'm thinking that kits for batteries, you're probably talking somewhere between $7,500 and $10,000 for a 24 module kit to do a RAV4. You maybe confirm that one way or the other. And then of course there's shipping and handling and everything else on top of that.
Yeah, I mean, I need to look at, you need to get the the charger and there's one part you need for the silver suitcase to go with it, and then you need an additional contactor to go under the hood. But I think, yeah, a parts kit would be probably in that 12-ish range, including those parts and everything.
Okay, that's great that you mentioned the contactors. And just for your own information, I've been doing quite a lot of work on the RAV4, having resolved a number of problems, even for folks down in California now. But I've been working on a Nissan Leaf battery pack conversion for a couple of years here now, and sort of in almost the pre-production stage here with quite a lot of success with a daily driver now for about 2 years, actively, much more active in the last year. And I was surprised to find that even though a 24 kilowatt battery versus 27 kilowatt battery, that the range is significantly less using the lithium batteries than what it was with the nickel metal hydride. And quite honestly, continue to be impressed despite the weight of the nickel metal hydride batteries. So just wondering, at this point, you mentioned 2 cars that you've got RAV4 conversions. Maybe one is a bit more advanced than the other, but the numbers you presented there are maybe more mathematical than on-road highway miles. And do you have any reflection on the math versus the actual highway miles? Because indeed, with the math, if you think about and maybe you've got an answer to that, maybe the Leaf battery pack math versus the actual highway miles, because in theory it comes out the same, but in reality it doesn't. And the question there was with the relays that you mentioned, that obviously you have done something associated with the original relays in the car in order to accommodate the new charging system and or the car running. And you and I should have a chat offline sometime.
Yeah, definitely we should. In answer to your capacity questions, the numbers on the RAV4 right now are very mathematical. They're also I would say cross-checked on the Ranger EV range. And so Lanny and I have been back and forth a lot about the 230 amp hour Rangers. And he's demonstrated, I think he did 205 or 211 mile range or something like that on the 230s. And so taking that and walking it back to the Ranger, to the RAV4, the numbers do match up. I think my answer to your specific question about the Leaf modules is that Leaf modules specifically can be very sneaky on their state of health. And so it's possible that it's not actually a 27 kilowatt hour battery. And that the state of health of those modules can, it may be a lot lower, capacity wise than the nameplate suggests. So I got a set of Leaf modules to use in some motorcycle restorations, and we actually tested them, and they had only had, I think, 20,000 or 30,000 miles on the cells, but they were coming in at around 35 amp hour, and they were supposed to be obviously in that 60 range, and so it's possible that the difference there is a degradation, sort of hidden degradation on the Leaf cells.
Yeah, I agree with you on that. I've been using the Leaf Spy app, of course, and indeed, it reflects there what the health and state of condition of the batteries are. And indeed, even a vehicle that's only got, maybe 30,000 miles on it or something can often be in a 70% capacity condition. So all that's good. Well, it's glad to hear that you've just mentioned Lanny there and that you're working with him. He's doing great work as well. And so good. Okay, thanks.
Yeah, thanks,
if I could, I know we're keeping over. I hope it's okay. A quick question is just: are you doing or know anyone who's doing actual just upgrades of Leafs? I mean, obviously, there's lots of cars. Some of them, there must be Leaf batteries available, or maybe there's something better to do. I know people with, early Leafs that like the car well enough, but the batteries are for shit now, and so.
Yeah, so we work with a company in Georgia or South Carolina. They're right on the border. I can't actually remember which side of the border they're on. Um, and they do exactly that, and they're fantastic. I can round up that contact information, and Jerry can send it out if people are interested. But basically, they do leaf upgrades, battery restorations, and they